At UCSB, biking is part of our daily lives. Us engineering students spend most of our time studying, and changing our bike brake pads after they wear out is not something we place on top of our to-do list.
The problem that we are trying to solve is the fact that changing brake pads can be very time consuming, and when you do change them, you're required to use tools and a lot of parts fall off. So what we're trying to create is something that will allow you to change your brake pads without the need of tools, and so that you could do this within seconds.
The current benchmark are the common bike pads that are seen on everyday bikes. However, as shown, it is difficult to change the brake pad without removing the tire. Furthermore, the entire mechanism has a lot of washers and nuts that to an inexperienced person can seem almost impossible to put back together in the same order. This forces many people to take their bike to the shop, which can be very time consuming. Finally, modern brake pads are only one-sided, so as soon as they wear out, it means another trip to the bike shop.
Our initial design was supposed to implement a spring in the shaft of the brake pads that would keep the rotating part from slipping out, but after careful consideration, we realized that using a much more simpler ball detent mechanism that will lock the part in place will be much cheaper and easier to use.
We decided to implement a rotating mechanism that would have a brake pad on each side. This way, whenever the current brake pad being used wears out, the device can simply rotate 180 degrees and you have a new brake pad to use. No tools, no falling parts.
Some of the problems that we encountered was the sizing of the mechanism. As the space between the wheels and the brake pad is small, constructing a type of housing that held the brake pad and can rotate proved to be challenging. The material we chose for our prototype was aluminum because it would be a light metal that would still provide strength needed to properly apply friction on the wheel. Our final product is heavier than regular brake pad cartridges, but it is meant to be a proof of concept. Further improvements can be made regarding the material of our mechanism, such as researching different manufacturing processes that would allow for the exploration of injection molding with strong plastics. Additionally, reducing the size of the rotating part of the device would be on the list for future improvements.
As you can see here, this is our finished prototype. Here's the attachment block, and it's easily connected to the calipers via a nut washer and a threaded stud that we inserted. Here we have our brake pad that can slide in and out. I'll show you a simple example over here on this side. Very quick, easy. And it's tightened based off of some screws so it won't slip out while braking. And we also have a ball detent mechanism that locks it in place, as you can see on this side, easily rotatable.